Galileo could not comprehend the idea that if string was composed of infinitesimally small pieces, then a longer piece of string would have a greater infinity of these small pieces than a shorter length of string. Rather than resolve this problem, he just gave up and said such infinities should not be compared. Cantor compared infinite sets, albeit in a bogus way, and concluded that most of them were equal to each other. Neither investigator gave a useful starting point for future work. Rather than thinking of ordinary string, it is convenient to think of line segments. These don't have a fibrous nature and are conceptually easier to divide into really small pieces. However, string is easier to say than line segment, so let's stick with the name string. If we consider the ratio of little pieces in each string, it is independent of how small the little pieces are. If we consider the number of little pieces per unit length, the ratio is again independent of this arbitrary choice of pieces per unit length. It seems that calling something infinite pulls in a whole lot of unhelpful pre-existing ideas. Infinite quantities apparently do not obey the ordinary rules of arithmetic. But little pieces of string, however small, do obey the ordinary rules of arithmetic. Double the length of string and you have twice as many little pieces. So we require a special infinity symbol which does obey the ordinary rules of arithmetic, as if it were an ordinary number. How you think about phi is up to you. How it behaves is not up to you. It follows the phi rules. Infinity has been quantified, so that different infinities can be compared. It is interesting to consider how one could test the older ideas of infinity by counting using a computer. The fact is that they could not be tested in that way because they are infinite. You can get away with this with school kids, but not with adults. If the theory can't ever be tested using a computer, then it is not scientific. So here is the Holy of Holies for the fictitious Cantorian Hilbert cult. Every 50 years they test the theory that A equals B equals C using a balance scale and carefully taking account of the weight of the buckets. Every time they make the test, A equals B plus C, and also B is twice as large as C. After 500 years, a novice asks the high priest, "Master, in all these 500 years, We have never seen any tendency for B to equal C. They have always been in the ratio 2 to 1. How can that ratio ever change? The high priest is undaunted by such a question. You just have to have faith. After 1,000 years, there are no longer any new novices, and the number of remaining members of the cult are very few. Many have joined and subsequently died, but nobody has ever reached Cantor's promised paradise. The lowest ranking member of the cult now speaks up. Master, there is no more gold to be found throughout the entire world. We cannot continue with our grand test, and yet we have never found B equal to C. Was our faith misplaced? The elderly high priest rises from his throne, a sad tone in his voice. I see now that we were wrong to question the infinite with such a test. You cannot test faith. You either have faith or you do not. We must ask forgiveness for daring to test the infinite. It shows that we did not, in fact, have enough faith. That is the only problem here. This marked the end of the Cantorian Hilbert cult. The members all dispersed, having taken up diverse interests such as calculus, statistics, and topology.